Oh, I think it's working now. I can definitely see something. Oh, okay. All right, all right. It says the stream health is good, so I guess that means it is all working. So, what was I doing? Pretty sure I was just wanting a map to generate terrain so that I can like test my map idea. I do think I need to make it bigger though. Um, uh, let's say 64 cells to a chunk. We'll just go back to something small that we feed into that. I guess we'll keep the actual points we're sampling close together, but spread the noise much further apart. We want to change this to 63. 63. This is technically chunk size. Like, why make a thing and then not use it? This is chunk size, chunk size. This is chunk size minus 1. Chunk size minus 1. This is chunk size. So you say chunk size. But no. Chunk size, and then this is +1. This is plus chunk size plus chunk size, and this is plus chunk size +1. All right, that should and this would be chunk size times chunk size, I believe. Then this has to be as use as Python a size. No, what are you saying? Right, because I've specified that. Okay, so we'll just see. I32. No, we'll just go back to U16, but we'll just say let's do this and say as U16. As U16. As U16. And then instead of doing +1 chunk size, we'll say Z +1. Maybe it's that we want to do. As chunk size. And these two will be Z plus that's the wrong side. Z +1 times chunk size, like so. Why are we multiple? Right, because they're I32s. Ah, damn. As U 16. As U16. Right. Right, and you want to be a U size, don't you? That should let me spawn like a reasonably sized mesh to like have some like terrain that I can view. In theory, I could also then quickly expand that to spawn multiple chunks and have an infinite like terrain generator, but that's not really required for what I'm doing at the moment. Maybe we'll build that after we get the camera working and call it a separate plugin. It's really weird with my volume not making any noise. It's just so bizarre. All right. So I'm going to use Bevy Rapier for the three or something. How do I do this? Ah, right, it's Bevy Rapier. No underscore 3D. Yeah, okay. So the plan is to use Bevy Rapier to like basically sample the terrain rather than having to write my own mesh raycasting. There's also, I think, Bevy mod raycasting, but I'm not sure if that's up to date. That would also let me do raycasting. The idea being that I don't just want the camera to stay a fixed distance above the ground. I also want the camera to sort of stay a fixed distance away from the point the player's looking at, but also not be allowed to go lower than a certain point to the ground to avoid it clipping into anything. So I guess one way to do that would be like put like a sphere around the player and not allow them to collide at all. Maybe use a player controller or something to be able to press the arrow keys and move the player around the pivot point. So we do have some nice big flat terrain. I do feel like we need to have slightly more variation in terrain height, but also I need to work out why the terrain's like unshaded like this. It's really weird. Like it does have it's got normals, right? Like points to no asset. Standard base color, emission texture. Double side, unlit. That's what it looks like unlit. So it's definitely getting lit. It's just not got normals that are like right. They're just flat. Probably got something to do with the fact that the normals are pointing like all pointing up, not out, which gives you like the light transitions perfectly smoothly because from here to here the normal doesn't change, and it's not possible to make this normal point in a different direction. I guess we could just give the normals a random value instead of pointing directly up. I don't know if this will work. We don't want to do that. We want to go new rand. Do I have rand? Or I've got noise, haven't I? Use rand as well, because we need some way of sampling randomness. thread random. I think it's been a while since I used rand. Like dot get or something like that. Okay. And then this would be 1, and then rand thread, oh, it's thread RNG, and then gen. Okay, I was close. RNG and then gen. All right, so that should give us like normals that are ever so slightly like randomized, so that the whole map doesn't end up being like a flat uniform plane. I have no idea if it's actually going to work. I could end up with it being really weird because, like, in theory, I think they can give you negative normals. Actually, shouldn't matter because the normal pointing back into the ground wouldn't cause a problem, I don't think. Anyway, we should probably start working on the actual plugin. So we're gonna call it a struct orbit cam, and then we're gonna go. There needs to be a component, so derive component. Now orbit cam. This should be done in the lib. Yes. Plugin. Import plugin. Oh, it did not like that. Weird. If I just rerun it, maybe. That was very strange. Gotta finish implementing this bit first. Plugin 4. We definitely need to use Bevy. Use Bevy prelude like so. It's just build, isn't it? Let me say app dot. No, we do nothing because. This also needs to be public. Alright. We come here and we go dot add plugins. No, it's use create no, what's it? It's not drawing a blank here. What do they call it? It's called orbit cam. Okay, so if we use 2.5 cam orbit cam plugin like so, and we'll just add the plugin so I don't forget to do it later. It does nothing at the moment, but we'll include that. It's pretty hilarious that I managed to make it to day 2 of doing the plugin jam without actually making it a plugin. Okay. See, it's still flat lit. I need to come up with some kind of way of unflat litting it, but anyway, doesn't really matter. We will we need to just like say like maybe 3, just to give it that little bit more noise. Maybe we'll actually reduce this to 3 instead, which is the equivalent of multiplying the other by 3 in terms of size to deviation. Why? Try that. So we're going to need a function which is going to be Okay, it does seem nice and wavy now. So we need to like have move camera, which is going to query. Cameras. So it's going to query for anything with a mute, transform, and an I guess yeah, everything with a transform with orbit cam. Okay, and then we need inputs, which is going to be res inputs. Touch inputs, graphic inputs, keyboard inputs. Oh, they've changed this since I used it. The button input. A pressable input of type T usage. Okay, and then we want to say like key code. Okay, and then we're going to say we need time as well. Res time. We'll add our app dot add systems update move cam. We'll call it cameras. Just right. Net. Okay. So we need to say for camera in cameras. I didn't like this. Okay, and then we say I guess technically we want to go let delta equal vec 2, I guess. Vec 2 0, and then if let's tweak this actually, and then we'll make this not with orbit cam, but instead so now it's just a query of orbit cam, which means we wrap this as a camera and config. Okay, so then on each of these laps, we're going to say if, so inside here we need to say, I guess, forward, which is a key code, key code. Alright, let's just go with up, down, again, key code, left, is also a key code, and right, which is also a key code. I got a key code. Right. So now when you add to a camera, you get to control the inputs that the player can use to move the camera. Oh, because it needs to be a reference. There we go. God, can you tell it's been like ages since I actually wrote anything in Bevy? So if delta dot x plus equals input dot pressed config dot x. So that's left and right. So it's left if it's positive. I think it's because we're pressing the right key as F32. Delta dot x minus equals input dot pressed config. Oh, no, config dot right as F32 delta dot y plus equals not y z. Right. Okay. So I'll make you a x3 then because there's no point not. Z plus equals input dot pressed config dot up as F32 delta dot what are we doing? Z, and then we're going to say minus equals input dot pressed config dot down as F32. Is that going to work? I was so looking forward to that just working. Okay. Then we say camera dot translation plus equals delta as vec3. We need to make immutable. So times time. I guess we'll make it a setting in here. We're going to say speed. Times time times speed. Times config dot speed. Time dot delta seconds. Okay. So this should allow the camera to have the fun effect of, as I press the configured inputs, which I've funnily enough checked right twice, it's actually supposed to be left. It'll move it around, like it'll update the delta, and then I'm applying the delta multiplied by the time that the frame took times by a configurable speed to move the camera. So that should mean that if we come back to main and we say when we spawn in the camera bundle, I need to say orbit cam, and we need to configure it to up. Oh, they need to be public. Okay. So up needs to be key code. W, key W. Okay, down is going to be key code key S. Left will be key code key A, and key, and then right is going to be key code key deep. And speed will be 100. It is a bit updated. Okay. So this is going to hopefully result in when I press the corresponding arrow key, the camera will move around, you know, in that direction, but not in the direction that the camera is looking. But instead relative to the world, which this is currently backwards, I guess, because the camera is looking this way. So what's next is we need to, I guess, work out which way's forward for the camera, but not actually forward. That makes sense. So this point here would be forward right now in the camera because it's where the camera's looking, but I want forward as in like if you pointed the camera at the horizon forward. So not quite sure how you would derive that. I guess you could use forward and then remove all of the y component, and that should flatten your your direction into the plane, and then you normalize it so that it goes back to being 1. So we'll take in the camera's transform. So we're going to say let forward equal camera dot, there you go, dot forward direction 3D equal to local dot negative z. The fuck is a direction? Huh. Weird. Anyway, I kind of need the underlying vec3 bit. How do I get to it? Like, how do I get the vec3 out of you? Is it public? Like, no. How? We can say new. We can say unchecked. New and length. Deref. Neg mul. Yeah, okay, so we can deref it apparently. Okay. So we need to make it mutable so we can actually do this. So we mute you. And then we say forward dot y equals 0. So we'll cancel any horizontal any horizontal direction to it. So if the vector's pointing downward, it now points straight at the horizon. We're just sort of flattening it up, and then we say forward dot normalize. So we need to normalize times delta times time times speed. So this should mean that forward is forward, but independent of down. Forward is just forward. So if I, okay. Oh, it kind of works, except that if I press up, it's heading that way, which is not forward. It has, in fact, flipped the script, but it's very weird. Forward should be this way, like up. I don't know why it's heading that way. And maybe it's just, can we print let's see what the normalized forward vector is. Because I don't get why. The y shouldn't matter. Oh. See, because I should move by 0.7.7. And if I go to my camera and go my transform, where is my transform? Global transform? That'll do. No, it won't. Why is it only moving a singular axis? Okay. I'm confused at why 0.77. So let's get it to print out the direction that we will be heading. And why is that direction a constant? Well, apparently it's 0. Because it's multiplying? Do I have to cross? How do I? Is it an ordered operation? Is that the problem? I need to multiply. That's probably it. I need to multiply delta by forward. No, it's going to have the same issue. I'm trying to think, because multiplying them, like it's obviously multiplying the 0 in the x and then giving you 0 on this. So we would just want to move by the forward. So I guess it's instead, if being plus equals this, it should be plus equals forward, I guess. So we say calculate our forward like so, and then we say times by forward. If we say forward equals forward dot normalize. So I don't have to keep normalizing it. Okay, so we say forward times by our button press, and then forward times by our button press. So instead of being delta x, delta plus equals forward times our button press. Why are you not working? Ah, because it's right. Fine. We'll turn it into a conventional if statement. I was trying to avoid branching for no real reason other than because it looked nicer. If in press config dot up, then you gain forward plus equals forward. If input dot pressed config dot down delta minus equals forward, and then we need to, let's copy these, paste them here. They get to be independent because left. It's actually probably right and then left, because I think right's the other one you get. And then, so you'd be, so we would just say right equals camera dot right. There's no camera dot left, yeah? No, there's a camera dot left. Okay, camera dot right. We dereference it, and then we say right dot y equals 0, and then right equals right dot normalize. All right, and then here we're going to say plus equals, and it's going to be right and right. And then why are you saying that I can't? Okay. Why is this not working? Oh, because it's an IVEC3. Yeah, right. Well, it doesn't need to be an IVEC3 anymore because we're not adding integers. Okay. So if you press up, it adds forward. If you press down, it subtracts forward. If you press right, it adds right. If you left, it subtracts right. And that should... Right, which means we don't need this anymore. I mean, this is just a printout, so that'll be fine. And then we can just say delta, and we can get rid of the forward normalize. And it's just delta times delta seconds times speed. So that should hopefully translate into pressing forward moves you forward, irrespective of the angle of the camera or the pitch. Ready? Okay. So, so next, I guess, is to go to the orbit camera and say the orbit camera also has a zoom level. No, zoom. It's going to be an f32. I guess we should call it min zoom and max zoom. Because again, I'm trying to make a plugin that someone else can use, and therefore, like, I don't want to set these with constants. But I probably will make the camera zoom its own like component. So with our camera zoom, this is going to be an f32. Like so, we should probably make a camera bundle then as well. Hub, looked, orbit, camera bundle. Derive component. No, derive bundle, isn't it? Bundle. And you're going to consist of a actually, I've got a better idea. I'm going to, for the sake of making it more like user friendly, and also just to show off some things you can do with Bevy, I'm going to make it automatically add the zoom when you add a new component. So the user doesn't have to worry about adding the zoom because the zoom is entirely managed by the plugin. And so the idea, which actually means it doesn't need to be public. The idea being that this is something I want Bevy to actually add, is the ability to, like, when you derive a bundle, to say, hey, this is the bundle. These are all the things you need to specify as the user, and then here's a bunch of things that will be using their default implementation or derived by the plugin itself. Will automatically add these, rather than having things like global transform. You need to define it, even though the global transform should never be set by the user. So we're going to have add zoom, and this is going to be a struct. No, it's going to take in. It's going to do. We're going to call it new new cameras, and it's going to be a query for entities with no, not with added the orbit camera. Or so if you add the orbit camera, added the other camera without camera zoom. Okay. We need commands because it needs to insert the zoom. And then it's just as simple as for cam in new cam commands dot entity cam dot insert camera zoom. We should probably do a reference to the camera itself. So we want an entity, and then we want to say camera zoom with cam dot max zoom minus cam dot min zoom divided by 2 plus cam dot min zoom. Which means if you don't specify a zoom level, it'll automatically insert a zoom level in the middle of between the minimum and maximum zooms. Okay, so we have our camera moving around, and we're going to say fn zoom camera, which is going to do something with mouse inputs. We want to also add this system to not update. What's is it? It's on first, and this is going to be add zoom. So first thing it does each frame, check to see if any cameras have been added that don't have a zoom, then update the zoom. So zooming the camera, we're going to need mouse wheel, which is going to be an event reader mouse wheel mouse motion. It's mouse wheel, isn't it? Yeah. Mouse wheel event. This event is scroll unit X, Y, window entity. Okay. And we need mute. Except it needs to be cameras. Zoom like so, and then we say 4 in cameras. We're going to say that zoom equal mouse event read dot sum dot map e dot I think it's y dot collect dot count. No, it's not count, is it? Consumes to counting the number of iterations and returning it. No, it's not count. It's sum. sums the elements of an iterator. It takes each element, add them together, and returns the result, and it returns the zero value of this type. Sum can be used to sum any type, implementing sum, including option and result. Okay. Right, it needs to be that can work? No. Oh, because you need to be mutable as well. Okay, and then we're going to say let me say okay, we need to say this to zoom and config. I'm going to say zoom dot 0 plus equals zoom. Right. Delta. You need mutable. Okay, so we say zoom plus equals delta, and then zoom dot 0 equals zoom dot 0 dot clamp between config dot min and config dot max. Okay. Not exactly sure. Like, oh god, how this is gonna work is what we kind of need to do. Oh, sorry, is to parent the camera. Zoom camera. We need to parent the camera like inside of a child, inside of an entity, so that when we move the camera around, the like we have like a pivot point around. But I don't actually want a physical entity to do that, because that would like mean that people using the crate would need to know that they need to manipulate the the child component, not the parent, like not the camera. Or I guess, yeah, they would need to know that they need to be controlling the like parent entity, not the camera entity, because the camera is a child of like the actual object that moves around. So, oh god, it keeps sneezing. We're gonna say if and update zoom, and that's gonna take in max wheel. So update camera zoom is going to take in a camera transform. It's camera zoom. I feel like the orbit camera is going to need a pitch and a yaw, because storing a pitch and a yaw would like then mean that I don't actually need a physical point, because I can just project that point while I do the math, and then the point doesn't actually exist. So we probably are going to need a like a pitch and a yaw. So we'll derive component struct camera pitch F32, and we'll do the same thing and make a yaw camera yaw. Oh god. I believe I need my brains at this point. What do we need to? We have the update camera zoom, and it's going to take in. It's going to have the zoom. pitch and the camera yaw. I might condense these all into a thing, but like again, these are all private things that you're not supposed to really be accessing when you're using the crate, and that's why the config is the only bit that's actually got all the public stuff. Okay, so I bet you know so we're gonna update the camera position. All right, update camera position, and that's gonna happen. So I think move zoom, and then dot. Okay, so add those two. Move zoom. Dot after. No, before. Dot before. Not a set. Can I just want to say update camera position? Like, am I allowed to do like just a singular system? Not quite sure. Seems to work. Then we just need to go add systems. This is going to run in update, and then it's going to update camera position. Okay, because it needs an accurate camera, like move camera and the zoom. So so we probably should call this we need to add pitch and add yaw as well. Add pitch. That's why you should probably condense it into a single one, because now it's getting a bit complicated. Orbit camera. See, they don't need that on these ones. So added orbit camera without camera. This is yaw without camera pitch. You don't need this. Okay. We can get rid of that. Get rid of that. We just say that we just add a camera yaw of 0 and a camera camera pitch of 0. Except it shouldn't be 0. Man, that doesn't really matter. Except we. Okay, the yaw can be 0, but the pitch should be F32. What is that? 3.14. Whatever that equals. It's not random. I just don't know what the number is. It's half pi, because I'm pretty sure radians. Like Bevy is just radians, which means that if I want it pointing at a 45-degree angle, pi would be 180 degrees. 2 pi would be a full 360 degrees, because there's 2 pi in a radian, I believe. Or there's 2 pi radians in a full circle, I think. But that, like, literally what defines a radian is that it's half a circle equals pi. So half of pi would then be 45 degrees. Or is that 90 degrees? So maybe it's divide by 4. If pi is 180, yeah, divided by 4. So there should be. I think I'm not sure. Radians always confuse me. So divided by 4 should put us at 45 degrees. So we always want the camera, if you don't add a pitch, to be pitched at 45 degrees so that you're not like looking along the horizon. Because, that's almost never the right situation. So add zoom, add pitch, and add yaw. Okay. Add zoom, add pitch, add yaw. Okay. So what we need to do is go for pause, pitch, zoom, zoom, pitch, yaw, and config. Right, and then we say in camera. Okay, so we have a mutable position. I feel like we also need to keep track of the actual position of the player's camera, because otherwise this is just going to keep moving the player. So I probably should have condensed them, but we're going to say maybe just inside the zoom we'll keep a vec3, which is going to represent the actual position of the player, like unzoomed position of the player, I guess. Because we're going to keep updating the player's position. So we're going to say let move equal to pos dot. So we need a mutable zoom as well. This is why I'm thinking I need to kind of condense all this stuff into like a struct that represents how the camera is positioned, so that like things like holding a position of the camera last frame is something that like makes sense, but I don't want it to be its own component. It could be, but I don't really want it to be. So move is going to be the positions transform. See, we need to keep not just its. We need to keep track of two, so we're going to literally have to start naming things so I can know what they are. Zoom. I'm getting a bit lazy now. The stream is going to end soon-ish because I've got other plans, but hopefully I can get this implemented in the next half hour. So what we're going to do is last, which is going to be the position we set to last, and maybe offset. Which is also going to be a great. So you then become like this, and we say zoom, and then we say last and offset. Okay. Might have been able to get away with doing it with just one. Like in my head, like something tells me that one is all you need, because you can work out the difference by subtracting the offset and then using the difference as the new one. But basically, that means that if you change the zoom or anything, you can't then calculate where it was. So the moved position is the current position minus zoom.last. So that's how much the player has moved since the last time we ran this calculation. And then the offset is going to be the amount we offset. So let center equal pos dot translation minus moved minus zoom dot offset. So basically we work out the difference between the position and the offset. Like in the last place we set it. So we worked out how much the player has moved. We then remove how much the player has moved from the player's position, resetting the player back to where they were last frame from our perspective. Which I guess no, it would be because like why wouldn't you just subtract, why wouldn't you just use last, because that's all that matters. No, it's take the player's position, subtract the offset, which gets us back, and then add moved. No, that still doesn't make any sense. Why would you use that? It would just be offset add moved. I think that might be right, because then the center is the offset plus the distance we moved, which is just like, say it was updating the offset to be correct. So the center is the offset plus the amount we moved, which we then like at some point need to be like zoom needs to. So we could, instead of saying center, we could just say offset. So say like zoom dot offset plus equals moved. Right. So now we're updating the offset with the amount that we've moved since the last frame. Then in theory, we can calculate the pitch to yaw and then like basically project the line out from 0 and then offset that line. So what that would mean is we need to go something like pitch. So we need a quote from rotation. So you need to rotate around the Y. Yeah, around the Y, which is the yaw. Right. And then we plus, or is it times? From the rotation around the X, yeah, X. You can't see this, but I'm like moving my hand to try and work out, like, yeah, so if I pitch my hand up and down, it's going around the X-axis. It's moving around the X-axis because it's sliding through the Z-axis. It's moving on the ZY plane. Anyway, so that's going to be pitch. Right. So we then we say transform from rotation, like so. So it's basically, we're gonna yaw around, pitch to the right, pitch, and then we say start equal your then we say dot forward dereference forward, go to the end, say forward times by zoom dot not last zoom. Right, so this gives us our start position, and then we say pos dot transform equals start plus zoom dot offset. It's zoom dot zoom zoom dot zoom and zoom dot zoom. Okay. Then we're going to come down here. We'd be like, okay, so minimum zoom is going to be, let's say 5, which is basically going to represent how close the player can get to the ground, and maximum zoom is going to be, let's say 100, which is going to represent how far away the player can get from the ground. So if it works, zooming in and out, like, cause I don't know which way the camera's going to point, because there's a good chance it's going to just be wrong and pointing in the wrong direction. Like, I don't know where that camera is. Does it have a gizmo? Where is the camera? What is its transform? I feel like its transform is making it fly away. No, it's, well, its translation is negative infinity. Well, that is interesting. Where are you getting infinity from? Something. One of these is suddenly equaling infinity. Okay, so I'm going to say start is equal, so from translation. Okay, we should probably like start debugging some of this stuff. So start is just going to be that. Okay, so then we'll be like print start. Right. And then we're going to say, we need to make mutable. Okay, so then we're going to say, we're going to say, let start equals start dot, oh, maybe we go start dot rotate. Is it multiply or is it add? That is the question. Then we're going to say print line so we start at 0, 0, we rotate 0, 0, then we're going to say print line forward, which is going to be start dot forward, right? And then I guess we just kind of hope that that number's not. Technically, I think we need to multiply by back, but anyway, that's not. Need to dereference you. Really? Oh, his transform doesn't include display. Okay, and then your start, which is just a transform plus offset. Well, for one thing, how did I pull that off? Because your translation is equal to, oh, and your rotation. So I guess we just need to say the we need to say like, come here, go like start plus equals start dot translation plus equals zoom dot offset, and then we say zoom dot last equals start dot translation. That's probably very quickly why it got to infinity. And then we say we dereference position and say the position is equal to start. Is that gonna work? Well, I at least found like one case where it could run to infinity. So that, I mean, it's gotta count towards something, I guess. Okay, so see, there's still a problem because it's still getting 0 each time. Is it still summing to infinity? Where's that transform? Transform. No. Well, I mean, it's moving. Why are you not 0? Okay, if we set these all back to 0, that'll put the camera here. I have no idea which direction the camera is pointing. It's either pointing down. It's probably pointing that way. Okay. We need to go. No. Okay. So rotate. Oh, I can't rotate it. Okay. So I need to move it into the center so we can. It's got to be looking up, right? Like otherwise, I'd be able to see the ground right now. It's got to be looking that way because that's the green. So it's just the pitch is going the wrong way. Okay. I mean, that seems like a simple fix. Is to say that it's not. It's starting yaw. It's going to be negative. That should yaw you down. I like how the frame rate, you can see it changes when I'm tabbed in and tabbed out. So okay. So this should, at the very least, point me in the right direction. Hey! Is the zoom even changing? Doesn't look like it's changing, but I mean, we can see the ground now. Everything else seems to be working. So it's probably I guess technically the pitch I can set. Like nobody can touch the pitch. They don't need to be able to set it, so I can leave it negative for now, at the very least. So what are we doing? What was I doing? Lost it. So updating the camera's position. Why is the zoom not working? We zoom the camera. Can we say print line wheel delta. And then we go, yes, hello, why? Okay. It's definitely getting a delta. It's just not actually changing anything. Does the camera's position get changed? It's detecting it. It's still just set at 3232. That's interesting. There we go. It's over here now. Okay. Can we get it to maybe print out what the zoom level is? Like, why is it not actually changing anything? Are you, like, have I somehow set this to only update once? No, it just runs an update. Right, I can see it's updating every frame. Is it because we removed the multiply? We did. There it is. Okay, so then we say start equals start dot forward plus zoom dot zoom. Okay. Dereference u plus times. Oh. Forward times zoom. Okay. Well, it went somewhere. I feel like the camera is constantly moving, just because otherwise why would it not be visible? Not you. No? So 32. It's over there somewhere. Okay, you can see the ground. And as I zoom out, I zoom out. Okay. I mean, that's working. Okay. I guess there's only like a few things left to do. Like to get like the very basic orbit cam going, and then I'm gonna call it for today. So we need to, it's not pitch, it's your FN your keyboard. Okay, we'll just call it your camera. I was thinking of doing like a like you can click and drag to move the camera, but I've just for now, again, like the simplicity's sake, I'm gonna say we have like your keys. Key code. Key. And then your right is going to be key code. Key E. Okay, so Q and E, or your left to your right. And we need to add those two options as config settings. We can do this, this. Come here, go your. Which means we should probably F2 them to move, but anyway. Say your left and your right. So we're going to say, down here, your camera, we're going to say input keyboard button. Cameras, which is going to be query for mute camera your, and then a reference to orbit camera. And then we're going to say if for your config in your cameras, say your middle, if input dot pressed, we need time as well. Maybe we'll make a your speed as well. Again, trying to make it very customizable. Your speed. Okay, we're going to come down here. We're going to go your speed. I don't know if 100 is going to be fast, slow, who knows. We'll come down here. We'll go if just pressed config dot your left. Then we're going to say your dot 0 plus equals config dot your speed times by time dot delta seconds. I don't know if plus is the right direction. We will have to check that. We say your right, and then we say minus config your speed. Okay, and then we go up here and we say that this is your camera happens here. So move the camera, we zoom the camera, you're the camera, all before we then update the camera's position. Ba-da-ba-ba-ba. Yep. Okay, so we zoom. We need to get camera a little bit higher out of the ground so that we can actually tell what's happening. Oh, there we go. Okay, so youring at 100 is just way too fast. I should have thought of that by the fact that it's in radians, which means 100 is going to be like thousands of degrees per frame. Hey. It's not quite working. I'm moving the camera, the directional light, not the player. There we go. Up. Yeah. Okay. So the issue is we're still, the camera itself's rotating when we're supposed to be rotating around a point. But as I said, that's all I'm going to do for today because I have other plans and must leave. So thank you all for tuning in. Have I got building very quickly? I mean, it still takes a few seconds. It's either because I've done this, which means that Bevy's optimized to extremely high speed, or just I turned on something, I think, like iterative builds in my like my cargo thing. But anyway, so as I said, I gotta run. So I hopefully will be streaming again tomorrow, and we will continue on, pick up where we left off, working on improving this even further. So like we orbit a point rather than like what's happening now, which is we're turning the camera, because what we need to do is actually like use the offset to work out where the player is looking and then spin the camera around that point. Anyway, it will be ending the stream.